inside the Google Classroom, you will see this collab exercises. Okay, you click on this collab under filter under collab. And in fact, I already solved the problem for you here. Okay. Actually, this is the solution for this exercise. It's already there. Okay. Now I just want to show you how to use this collab and get yourself familiar with it, because when you write the code here, it's command line interface. There's no graphical interface. It's all command line. So how to use it and what you should do. So please listen up, because otherwise you are not able to use collab effectively. Okay, first thing first. Under this, okay, how to get there? When you get into Google Classroom, you go down below, collab exercise. Okay, the first one is QDA under collab. So you click on that and click on GPU example. Click on that, and this will pop out. Okay, this pop out. Okay, and you can see the instruction there before running this code here. Make sure that the GPU is enabled. So GPU is enabled by go to runtime, change runtime type, and select P4 GPU under hardware and software. Actually, what it says here is this: go to runtime, go to change runtime type. Okay, P4 GPU. I already select for you, so it's there. Okay, but if you create your own what they call notepad. Sorry, not notepad, notebook. Okay, this is an Python notebook. If you create a new one, you have to select this. Because I created it for you, so I already selected. Okay, so in your case, it's already set nicely for you. Okay, so you got 3 different GPUs. This is slowest of all the GPUs, the older version, and we only have access to this. So this is one. Okay, but take note, when you use this, you have 4 times. That means per day you have certain sorry, not per day. For a certain period of time, you only need certain quantities. You finish it, then you have to wait. You have to wait until you reset, maybe the next day, then only you can use it. Okay? So if you want to use this, make sure that you do the exercise. Once you finish the exercise, you disable it. Okay? I'll show you how to disable it. Okay, you save it, right? Now you're not connected yet. Until you press this button down, you get connected. Okay? Or you run this. It means that there's no GPU there, there's only CPU. Okay? I'll show to you also later the difference between enabling the GPU without the GPU. Okay? So right now with the GPU, okay. Whatever that you see here is actually in cells. This cell. Okay, this is one cell. Top there is another cell. This is another cell, and this is another cell. So there are several cells there. Okay? And you can add new cell. How do you add the cell? You either click here or here. Okay, you can add 2 different types of cell. One is a code cell, the other one is text cell. Okay? Or you can go in between these cells and choose whatever type of cell that you want to create. Let's say, for example, here, I want to create another cell in between this cell and the previous cell, right over here. I can click it. Can you appear? Okay. Okay, this one is actually has an AI running behind. It's actually watching what they're doing. So whatever you type, you can guess what you're trying to do, and then you can suggest it. Complete it. Okay, it's not just code completion, it's actually studying what you have written down there. And when you type, you can guess what you want to do. Okay, it can help you. Okay, you can use this AI to help. Or sometimes when you run, you have error. Then Gemini is AI from Google. You can see your error, and then you give you a suggestion. Okay, you click on it, and then this panel will open. You print out what error it thinks is all about, and then it can suggest the solution. So you can use the Gemini. You don't have to enable it; it's already enabled all the time. Okay, it's suggesting for me this. So you see me writing this. It suggests that maybe print hello world. If you want this, we press tab. Press tab, and then it gets written down there. Okay, tab. It suggests to you if you want it, press tab. If you don't want it, just ignore it. Okay. So you can print hello world. Let's say I want to print many times, so I can use what it's already written for me. So I just tap like that. Okay. It knows that I want to do this, so it already suggests. So actually it's quite good. But unfortunately, this AI is only helping you when you do Python only. If you do C++, it will not help you. Okay? Only in Python. So it already suggests to me here. So things become very simple because actually AI is helping me write most of the code. Now I want to call pre-menu. So it knows that I'm going to call pre-menu, so it suggests to me that. Okay, so I can run the code. Okay, this is a function. And when I print for loop from I range 10, it means 10 times you print out hello. So this is my code, and you can see the result there. You print out hello world 10 times. Okay, and this definitely needs to define this function. So this is how we run the function. Okay. And we can write code outside the function. In Python, you can do that. In C++, you cannot. Your statement must be inside a function. In Python, you can do that. Now, since it is only for Python, then how do we write C++ code? Okay, we write C++ code like this. It's more step. Because here you write the code, you can run immediately and get the result. But if you write C code, it's a bit more tedious. There are several steps that you need to do because it doesn't understand C++. Okay? So what we want to do is we write this code into a file first. So write file, hello.c. That 2% there is having this notebook, this Python notebook. Whatever that is command next to that is not a Python code, but it's an instruction for you to do certain job. That job is to write file. It means that. Okay, so write file, write this into this file, not hello.c. Okay, so if I play this, you write the file, and you can check the file appearing here. Okay, you click on this. This is the runtime. Secondary storage that we have for this machine, and it's given to me 51 gigabytes, so it's quite a lot of space. Okay, so when you do your assignment using GPU, you can upload your data, your sample data, okay, or you download from the internet. I'll show you how to download from the internet. The data, you download it, and then you can run your code here using the data process. Okay. You can upload it, you can download it from the website if you want. Okay, so I already written this into the file, so that's the first step. First, write the program right into the file. Next, okay, I'm going to delete this because this one not supposed to be there. That's all. Okay, to delete the cell, you click this. You hover your mouse onto the cell, and then click this delete. If you accidentally delete, you can always press Ctrl M Z. Then you appear again. It's undo. Ctrl M Z. Okay, that is to undo what you have done. If you accidentally delete this, okay, so you go Ctrl M Z, then it appear again. Okay, so next. Oh, sorry. Okay, next is to compile. After I've written this, I want to compile. So I compile using MVCC. NVIDIA C compiler. Okay, and this is how we write it. And here is different from just now. We put bash, we put exclamation mark. The exclamation mark is different kind of command. Just now, we are asking IPython to write that code into the file. Now, we are asking IPython to send this command to the command line interface, which is our bash. In Linux, they use bash. So bash is just like our command line interface of PowerShell on Windows. Okay? Send this command bash, and bash will execute it. Okay? So what it does, it will it will launch this NVIDIA C compiler, and then compile this hello.cu, and the output file is called hello.out. Okay? Now you can put like this if you prefer. Some people write like this. It's up to you. You can do like this as well. Okay? That means you compile this file, and the output file is like this. Okay? I think it's easier to read like this, right? You can write like this. Okay, you can play this. Play. If there's no error, that means it's fine. If there's error, let's say I remove this. If I make this change, I have to save it again. Save again. And then when I play, you see the error. Okay, the error. It says that expecting this comma before this. See, it's missing there, right? So I have to put it. Okay, put it, save. Okay, run again. And when it runs, you don't see any error. Okay, if there's no error, it means correct. Okay, the next thing is to run the program. How do you run it? You run the program by writing the name of the file, hello.out, and then you must prepend it with // The // is to tell the command line interface, look into the current folder. Dot means current, / means folder. Okay? Dot current folder. So look into the current folder, look for hello.out and run the program. Okay, if you don't put it, it will not run. Okay, because bash is quite strict. If you don't put it, it will start to think that you want to run this file somewhere. Okay, maybe in another folder. So it will search other folder to look for this name. Okay, first thing is slow. Second thing is it happens to have hello.out somewhere else, it will run that copy rather than your save. So sometimes you make a change, you find out how come your code is different. It's because of this. Okay? So in order to reduce that error, you put this /. Because if you put /, you always check the current folder on looking for this file. If it's not there, you generate error and tell you that the file is not there. So that you know you're not going to run any other files rather than look yours one. Okay? So do this in order to get the result. So you click play. And you see hello world. This hello world is because of this hello world. Of course, you can add some more if you want to. Let's try another one. Okay, you can do maybe hide that. Okay, save it. Compile it. Make sure there's no error. Run it. Okay, so there are 3 steps to do. It's unlike Python. You write the code, you play it straight away. Here is different. You have to write the file, compile it, and run. Okay, and you can see the result. Hello world, hi there. Okay, hello world, hi there. Okay? Okay, next. So this one is very simple. It's just a simple exercise to do hello world. Right? The next is to do this exercise here. Q3. First, we want to run the serial vector app, and then we have to run parallel vector app. Okay? Sorry. Okay, we have done this exercise before, right? So qdar.kernel.ch, we save it as a file in there. So this is a hidden file for the qdar. And then this is the parallel vector actually comes from here. Comes from this file. Is it parallel? Yeah, parallel. So parallel is this code. Actually, I got it from here. Okay, I just copy and paste it here. But I made some changes there. I changed the name sorry, the name is the same here. But the name here I changed. I changed it to parallel vector add here. Okay. This one is vector add channel, I did not change. This one I changed it to this name. Okay. That's all that I made. Okay, next thing is this one I did not change. Okay. And then here is CUDA test run. Now CUDA test run, I mix a lot of changes. Okay, first thing is the serial vector add. Actually this code comes from here. Comes from serial vector add. You go in. Records. Okay, it's from here. Okay, this code here. Okay, I copy this whole thing and I paste it here. Okay, and then I made some changes there. I refactor the code, so I got init vector. So this is the same code as this what you see here inside the main. Okay, so you allocate the memory. For vector A, vector B, vector C, initialize all the vectors. Vector A I initialize to incremental number. B also incremental number. C I initialize all to 0. Okay, and then I run the serial test run. First, I create the pointers for and then I initialize the vector, create and initialize the vector ABC, and then I do serial vector add, passing to A, B, C and the size. Okay? And this is done by a single CPU core. I solve the vector add, and then I print the first 10 result, and I free the whole memory that I located. So this is for serial test run. Now for parallel test run, also the same thing. I have this double ABC, which is pointed to all vectors, and I create the vectors and also initialize the vector ABC. And now ABC will have their own memory and also the data, and then I use parallel vector. This one is solved by the GPU, multi-cores. Okay, and then it print out the first 10 results. So it's a code more or less the same like this, except that this part is different. Okay, only that part is different. The rest are the same. Okay, and then inside my main, I call the serial test run and I call parallel test run. So you see two results. Okay, you can save this. So I think this one I haven't saved. Save it first, and then you can check here whether it's there. Okay, CUDA-test.cu, parallel vector.add.cu, CUDA-kernel.cu. So these three files is needed to compile. So let's go down and compile it. So here is the place where you need to compile MVCC, and the output file is called CUDA-test run, and the two input file is CUDA-test-run.cu and then parallel vector.cu. These two files here. Okay. When I play, if there's no error, you'll produce the code here. If you don't see it, press refresh. When you press refresh, you refresh it. And the code is in. CUDA-test run. Okay? So I can run the code. / means current folder, test run this file in this folder. When you run, you see the first result is by the CPU, the second result is by the GPU. So the result must be the same. Okay? Because even though they are run by a different processor, but they give you the same result. Okay, so what happens if, let's say, I run without the GPU? Here I set with the CPU, right? Okay, I can run without the GPU. You can go here and change it. Click, go to change runtime. Okay, I can change it to CPU. Now, I suggest that you use CPU if you are doing something other than GPU. Okay, if your code don't have GPU, don't use GPU, because if you use GPU, you have limited time to use. Okay, if you use for certain hours, then you will not allow it to use anymore. Okay, but CPU no. CPU there's no limitation. You can use whatever, how many times that you like. Okay, this will be useful when you do OMP or MPI. Let's say you want to use a PC, you can use Colab. Inside here. Okay. So let's do some exercise. Let's try to change it to CPU. Now, once I change the CPU, it gives me a warning. It says that if I disconnect, it will delay the runtime. What it means is this: whatever that I've done here is gone. If I change it to CPU, okay? So this one will be gone. It's fine because I got it in my notebook. I can play it all again to get them out. Okay? So I say yes. Okay, I want to change my from GPU to CPU. So I save it, and you see all disappear over here. Okay? Right now you open up. Actually, it moved my notebook into another machine. Just now I was in a machine with the GPU. Right now it moved me to another machine without the GPU. Right now it's all gone here because I'm on a different machine. Okay? And I can play a game by clicking this button, but there are so many of them. I don't want to play one by one. I can go to runtime, run all. Okay? When I run all, you can see that all of them run, but they run in sequential. Right? We start from the top, run this, successful, run this, run until the bottom. Okay, so right now it's all running. Okay? So I get the same result. But the result here, the bottom part here is blank. You see all zero. Why is it zero here? Because I run using CPU. I don't have GPU there, no T4 there. So no GPU, it will give you wrong result. It will not give you error. So take note of this, it will not generate error. Okay, you need to be aware that if you see something wrong, check first whether your GPU is on or not. If your GPU is not on, no GPU code is going to run and therefore no result. Okay? Why is it zero? Because my vector C is zero. I initialize the zero. GPU is not doing anything to it, so the result is still zero. Okay? That's why you see zero there. Okay? Alright, this is the result from the CPU, so no problem. CPU will run it. But this GPU. Okay, so right now I want to switch back. Change runtime, go to this, click OK. It says that it's going to delete all this. It's alright. Click OK, click save. So it's all gone. It's fine. Connecting right now. And I can go back to run again. Run again. So it run all over again, but this time with the GPU. Okay? Okay, the GPU has quite a lot of memory. I'm using 1 gigabyte. I have roughly about 13 gigabytes. So this GPU is quite a lot of memory for you to play around with. It's the same for this PC as well. I think it has also the same amount of memory as well. So this is a GPU memory. It's not the CPU memory. The CPU memory is a separate memory. Okay. So right now I'm back with the GPU and I have the GPU result. Okay. Now one thing about running this GPU, you want to optimize it. So if you want to optimize, you want to see clearly how much time that you spend running which part of code. Because you can see that there are quite a lot of things that is happening here, right? You can run this code, you can run this code. But how long that you take in order to run the code? You use this program. This program is called NVIDIA Profiler. Okay, NVIDIA Profiler is the profile of the code. So what it does is this. The first thing, you run your code like normal. So it shows you the result, and it also shows you the result of the GPU. So this one is serial, this one is GPU. Okay? But if you scroll down further, you see the breakdown. Okay, you see the breakdown of function calls and also kernel calls. Okay, the first three is the activities run by the GPU. Okay, this one is the one that we want to look at and optimize. The bottom one is the API call, most probably run by your CPU. Okay, calling the QDAR libraries, and this is how much time that is spent. Okay, this one we're not interested. We're only interested in the GPU. Okay, if you look carefully at the top here, actually it takes about 98% or 99, yeah, 98% of the time to do this part here. Okay, and let's look at it. What is it solving? About 98% of the time, is doing memory copy. Memory copy. From host to device, device to host. 98%. The other 2%, less than 2%, is used to do vector addition kernel. Very small, right? Okay, let's look at the size of my problem. My problem is size is 1 million. Okay, times 2 is 1 million, right? Okay. It means that this problem is too simple, either too simple or too small. And of course here, actually 1 million, maybe it's small. And also the algorithm here is too simple. Okay? So this is indicating to you that this is not a good project to use, to do. Of course, this is just an exercise. Don't do this kind of, don't choose it title as an assignment. Because you will tell me, oh, even though I use 1 million, I use 10 million, I don't see any performance gain. How are you going to see any performance gain? Because your time taken to solve the problem is this much, isn't it? Most of the time you spend in copying. So this is not a good project title. Don't choose this kind of project. Because no matter how big you use the data, it will never give you any performance gain. I'll show to you later on some example where we can apply GPU and we can see the performance gain compared to the CPU. Okay? That will be a good project, but this one is not a good project. Okay, not a good title to choose. You can test and play around with it to see whether it is a good title to choose. But normally, if you see the code here very simple, it means it's not a good title to choose. Okay. Okay. Now I finished this. I want to move on to the next part, where I want to show to you some more challenging kind of code. Okay, if you go to collect exercise again, if you try this second class, learning image product, I choose this because I have a CPU code inside it. The rest I don't have CPU code, but this one is a bit more complex. I give a CPU code there, and you can run the CPU code and you can see the result. Okay, and then the exercise here is for you to change from single core to multiple core in CUDA. Okay? So I written for CPU, and then you refer to that code to write your GPU code. Okay? So I choose this because I have the code inside. The rest I don't have. The rest you have to do yourself. But this one I help you a little bit. Okay, the title says image blur exercise. Basically, you take one image and you blur it. Okay? A sharp image, you blur it. Okay, how do you do it? You can do it using OpenCV. Okay, OpenCV has this function to do blurring. But this, we do it ourselves. So first, I write the code in CPU, for CPU to run. And then you change the code to GPU. Okay? And then run the code. And then do performance comparison. Okay, let's see. You can upload your own image here by clicking upload. Okay, if you see too many sessions here, because I opened too many of these GPU sessions. So you can manage it. You tell me that I have one session that is running here. I can cancel it. Cancel it. Now I can use it here. Because Google don't allow you to open too many sessions. Okay, so I opened just now, so I force it to close. But you don't have to worry that even though it's closed, the runtime is deleted, but your notebook is still there. Whatever that you change in the notebook is not affected. Okay? Okay, here I want to do image processing. I can click on this to upload the image. If let's say I have some image here, which I don't have at the moment. I don't think I have any image, any pictures. Don't have, no pictures. Okay, never mind. maybe you try some. Maybe you can upload this file Wireshark just for demonstration. Actually, it's nothing there. Okay, I can click on this. Sorry, click on this and click on. Sorry, I need to connect first. Now it's connected. I can upload. Maybe upload Wireshark. Okay, so you upload it. You can upload the image there. But upload Wireshark. Okay. Now, if you don't see appears after you download it, now it's already done. But you don't see it there because it takes time to refresh. And you can force it to refresh by clicking this button. Okay, when you click it, you refresh and you see the Wireshark. So I upload from my PC. Okay. So this is in my Google Cloud. And I uploaded this the file. Okay, you can upload image or whatever data samples that you want to process with Python. Put it there. Okay, and I have quite a lot of space there. 51 gigabyte of memory. Okay, so you can put quite a lot of data in there. Okay, but here in this exercise, I'm going to download it from the internet, okay, from the web. You can use this wget. This wget is a program to download from a website, HTTP website. Okay, so I download the first one is linear image. Second one is a rose image, and the third one is a bigger file, image file, is elephant image. The last one is quite huge. Okay, it's high resolution and it's huge, about 1 megabyte of data. So I download it. So once download, we tell you that it's download 100%. Okay, rose 100%, and the last one is elephant. Elephant one is about 1 megabyte. Okay, the rest is very much smaller. Okay, once downloaded, now I can go ahead to do the exercise. Okay, here I mentioned about the problem about collab. Okay, collab, you want to display an image, you can write Python code to display the image, but you have to write in Python code. If you write in C++ code, you cannot display in a cell. If you want to display, you have to double click here. You double click, then you appear on the left hand side. But you have to take this action. That means you have to manually go, double click, and then you see the image here. Double click, then you see another image. Right? Double click here, and then you see another image here. But this one is manual. Sometimes it's quite troublesome, right? You want to see your result immediately. So you want to run the program, and then the program display here in the cell rather than clicking and then display on the side. Okay? So this cannot be done inside this notebook. So I write this program, 3 files there, to help me display on here. Okay? So the code is written, pre-written. You don't have to do anything. You just play on it. Okay, it's kind of lengthy also. I write text there just to explain what is happening inside here. Okay, so these are the files. The first file is a header file, just play. The second file is a C++ file, just play. And the last file is a Python code file, play also. There are 3 files there. You just need to save it. So there are 3 there. .cpp, cvpipe, cvpipe.h, runner.py. Only these 3 files. Okay, you don't have to understand this code, it's fine. It's lengthy, I know. You don't have to read it. I just write it there for those who are interested to understand what is going on. Okay? Yeah, your main program start here. Main program of the image blur. Okay, so what does it do? We open the file using OpenCV. Okay, open the file using OpenCV. Okay, this part here is quite lengthy. It looks scary also. I'll explain to you in practical 5. Right now you can skip first. Just look at this. Okay, I read the file from the user, and I load the file into the using OpenCV to help me load into the memory. And then I call image blur. So this is the image blur where you do the blurring. After doing the blurring, you show the image. Here is just, I write the code here, you resize it. Sometimes it's too big. I don't want to display too big. I want to display smaller. So this code is to check whether is too big or is just nice. If too big, bigger than the max size, you will rescale or resize it before you print out. So that's all that is done. It's done there. Okay, and finally the image will be shown. Now this is the main file, but where is the code that do the image blurring? The image blurring is done here. Okay, this is quite a big function there. This is the code to do the blurring. I won't explain it now, but if you want to understand, you can go to chapter 9. I will explain in chapter 9. But you can go to chapter 9 have you. Chapter 9 explains the theory, how actually you do image blurring. And there is some pseudocode in there, not full code. Here is the full code that I wrote. Okay, it might be different from the chapter 9 because chapter 9 is just a pseudocode. So I write here in C, okay, or C++. Okay, so here is a working program. You can play it. So I write into the file called CPU image blurrer.cpp. Right now I'm ready to compile the whole program together and then create an output file. The output file is called CPU image blurrer. This is the input file. CPU image blurrer, which is on top there. Image blurrer, which is the main file, to open the file using OpenCV, and then read from the user what file that he wants, and then call the image blurrer to process it. And then also pass in this CD card. This is the one that helped me to print on the image on itself. Otherwise, I cannot print it. Okay. And the last part here is the OpenCV library and the flag. Okay, because it's very lengthy. There are a lot of libraries to add in here. I'm lazy to write and also lazy to go and find. So I asked package config. Package config is the program that is used to install OpenCV in this machine. Okay, so it knows what kind of library, what kind of flag for me to use. So I asked package config, please go and find out what are the files of the libraries, what are the flags that is needed for me to compile my program. And then when you find it, you will paste it here. Okay, so it's not this. You're going to find it for me, and then you paste it here. Okay, it's going to be very lengthy one, but we don't care about it because we ask package config to do it for us. So what I'm interested in is just to play the command. Play it, and then start to compile. If there's no error, it will. Okay, there's an error there. Image blurrer. I think I missed one. Image blurrer. Is there image blurrer somewhere? Huh?
Maybe not.
This one.
This one.
Yeah?
This one.
No, I didn't play it. Not this one. Is it this one?
Oh, yes.
Forgot to play this, is it? Okay, let's try again. Yeah, right. I forgot to play that. Okay, so right now it's all there already. The file are all there. Okay, so I already run the program. You can see the image down below there. But here is the place where I run the program. So I use Python. This is Python code. So I asked Python to execute my program just now. Okay? I don't execute myself because I execute myself, it will not print the image here. So I asked my program, my runner file, which is I wrote up there. My runner file contains this execute. So this execute is to execute this program inside Python, and it takes in this image, linear, rows, and elephant, and then I specify some flag. I say the blur size is 12. Okay, the blur size is 12. If you make it smaller, it becomes sharper. If you make it bigger, the image becomes blurred. Okay, so I choose blur size 12. If you put 12, it's going to be slower. If you put smaller number, it's going to be faster. So I purposely choose 12 because I know that it's going to solve very slowly. Okay? So I choose 12 and I play. Now the Lena, you process quite quick. Okay, Lena is blur. Rose is also blur.